Hello guys, so in this video guys I'm just going to go ahead and continue on how to use these ratios in solids. Again, recently if you check out that previous video, I went ahead and I showed you how to find the scale factor between two solids, actually how to determine if they were similar to begin with. So today I guess I'll go more in detail as to what these numbers are and how to go from scale factor to area factor or area ratios uh, to volume ratios or backwards, doesn't really matter. I'm going to be using the following calculator here, the Desmos one. Again, it's free, you don't have to download it or anything, but you do need access to the internet. And that's it. We don't need any actual formulas guys, nothing on the formula sheet or anything for this part. So here we go. We have here number one. I borrowed this from number one we did earlier. And we're going to be dealing with this first part. So they give us lengths, right? Anytime you're given length of any kind, and you create a ratio out of a length, so any ratios out of length will be considered to be your scale factors. So earlier that we said that the 9 corresponded to the 18 and we got the 1/2, that is your scale factor. But at the same time, it's just your ratio of your sides to lengths. This is just saying that this one is bigger than that one. That's all it's saying. Now, remember that when we write ratios, sometimes you'll see it in fractions, and sometimes you'll just see it with like a colon in between. It's the same thing. Now, it does not matter, guys, what which number you start with, right? Like right now, I started with a 9. I could have started with a 4 instead. But no matter what, if the figures are similar, you're gonna end up with the same thing. So if you're ever given multiple lengths, just pick one. It doesn't matter which one, and that's what you're gonna use to find your scale factor. Again, anything related to length is your scale factor. So if you get a word problem, and they mention the word height, they give you the height in one and the height in another one, they're giving you the scale factor. Radius, diameter, these are all lengths. Now, as you notice over here, your scale factor is usually in terms of A and B. So I already here simplified, I have this 1/2. This is my scale factor. Our area factor, our area ratios, and this includes anything from just surface area to lateral area, anything that has the word area in it. Normally, to get area, you multiply two sides together. And so, if you kind of think of it in that route, it makes sense why to calculate your area ratio, we square our A and our B, which in this case, this is this 1 and this 2. And that's it. For our volume ratio, and just keep in mind what volume represents. When we're dealing with units, volume usually has something in cubed. And again, if you think of it that way, it makes sense why you have things raised to the 3rd power. And there you have it. So our scale factor is just 1 to 2. Our area is 1/4, and our volume is 1/8. Let's look at another one. Again, anything that relates to side length doesn't matter. So here, we could focus on the 42 or the 63, doesn't matter. We're going to get the same thing. So 42/63. I'm going to put that in my calculator just so you guys can see we get the same thing no matter what. Come here to my calculator. 42 over 63. Oops, I didn't even type anything. Now when I simplify it into fraction form, again, fractions usually what I'm after, 2 over 3. And I would have used anything else. Look at this, whoops. Now when you're finding the scale factor, guys, make sure you're using one of each. I don't know why I did 42 to 63 here. 42 is this side right here, and it corresponds to the 24, right? So let's make sure we're keeping things corresponding. It's very important we keep things corresponding there. So 42 over 24. All right, and again, I care about the fractions. So 7 over 4, 7 over 4. If I would have used the 63 with the 36, I should get the same result. And I do. All right, I do. So 7 over 4, and that's pretty much our scale factor. This is our scale factor. Usually represented as A over B. So now we know that A is 7 and B is 4, basically. If I wanted to find my area ratio, an area ratio is, you're going to square them. We know that A was 7, so I just need to get 7 squared. And we know that B was 4, so I just need to square that as well. 7 squared is 49. 4 squared is 16. I haven't had a need for the calculator yet, so I'm not going to use it yet, but I have it there just in case. So for my volume ratio, things get cubed. A is still 7. Notice how, that doesn't change. And B is still 4. That doesn't change. So here I will go ahead and use my calculator. 7 cubed over 4 cubed. And the neat thing about this calculator, you could write it just the way it looks. 7 cubed, 4 cubed. You press enter. Let's convert that to the fraction. So 343 over 64. And that's it. That's how easy this stuff is, guys. Okay. This one, they're not giving us a picture, but they straight up, they're telling us, hey, the ratio between two similar solids is 5 to 6. Okay. This ratio is technically your scale factor. Okay, this is your scale factor. And I know might not be super obvious that it's your scale factor, but it's your scale factor. So our scale factor here is what they gave us already. It's already simplified, so that's perfect. Now the one for perimeter, again, if you recall from our lesson on similar figures, your scale factor and your perimeter ratio are honestly the same thing. So do remember that your scale factor is equal to your perimeter ratio. And it makes sense if you really think about it. And now if I wanted to find my area ratio, I have to square the 5 and I have to square the 6. So 5 squared, that's 25. 6 squared, that's 36. For my volume ratio, I have to cube the 5. When I cube the 5, I get 125. When I cube the 6, that one, I'll be honest, I don't remember. So I'm going to come here. I'm just going to put in my calculator. So again, I got to cube it. So 5 cubed. And then we have 6 cubed. And I care about the fraction, right? So we have the 125 and the 216. Very repetitive after a while. And that's it. Okay, so this is what you do again when you're given your scale factor and you want to get your area ratio, square it. If you're given your scale factor and you want to get your volume ratio, cube it. Okay, don't forget, square to get your area, cube to get your volume. Now what if you have to go backwards? Here on this example right here, we are pretty much given our surface area ratio. If they give you two surface areas, you can make a ratio out of them. In this case, it is 1088 over 425. What do I recommend? First and foremost, very first thing is make sure you could, that's the most simplified. So we're gonna go ahead and put that in our calculator and see if I can simplify it. Because if I can, it's gonna make our life easier. Look at that, 64 over 25. It's a lot easier to work with. 64 over 25. And this is very important because remember, originally when we had our scale factor, we would have to square to get our area ratio. And so in order to get our scale factor from area, we're going to have to square root it. So that's what I'm going to do. To get our scale factor, from any area ratio, we square root. So what is the square root of 64? Well, the square root of 64 is just 8. What's the square root of 25? Well, the square root of 25 is just 5. And the cool thing about this is, now that I know my scale factor, which is usually A over B, now I could find my volume ratio. Our volume ratio, remember, all we have to do is just cube it. Scale factor cubed. So 8 cubed over 5 cubed. And again, I am going to come here and put this in my calculator to make my life easier. And I care about the fraction, 512, 125. And that's it. What if, another example here in the bottom, what if you're given the volume ratio? If you're given the volume ratio, to find your scale factor, instead of square rooting, you're going to have to cube root it. Cube root is something that you guys are not familiarized with. We don't do those too often in geometry. But the cube root looks just like a square root, but with a little 3 outside instead. And since this is mostly something that you're going to do on a calculator, it's not a big deal at all. So as of right now, again, our volume ratio is a 1944 over 9. And again, the first thing I'm going to try to see is if I could even simplify this. So I'm going to come with the calculator and see if this can get simplified. And look at that. It simplifies to 216. 216 over 1 technically, right? So what I'm going to try to do now is I'm going to try to find the scale factor by, again, doing the cube root. So I just need to find out if there's a cube root for 216. And there is, it's 6. Now that I know my scale factor, I can easily find my area ratio because it's just squared. So this would just be 6 squared, which is 36, and 1 squared is just 1. And voila, I am done. Okay, so again, just see how if you know your scale factor, square to get area, cube to get volume. If you're giving your area ratios, square root first, and then treat it normal. No matter what, guys, if you are not given the scale factor in the beginning, notice how that was always the very first thing I did right afterwards. Okay, you need your scale factor to find the other ones.